Okay, it looks like we're all set here and going with our webinar today. Um, welcome today to again this webinar. Right now we have a very small class. I'm not used to really having small classes, but sometimes we do, and that's good. My name is Tom Wilder. I'll be your instructor today. I have 6 years experience with the Department of Labor, and prior to that I worked 28 years in various safety training and quality management positions in the textile, machine assembly, and pharmaceutical industries, which most of those years were in pharmaceuticals, for which I'm retired right now. So anyway, glad to be here today. Glad you're here. And logistics for those of you who have never taken a webinar from us, look around your work area and try to limit any distractions. If you have an office door, you want to close it, turn your phones off, or if you're in a cube, use headphones and put up a do not disturb note. Our tool that we use today is called Webinado. You'll see the PowerPoint slides in the center, and I'll advance those as we work through the class. In the bottom left, you'll see an emoji. I will not be using that feature, so don't worry about that. But we do have a chat box, which you've been using. So if you have questions or comments, you can chat with me during the session. I'll take comments and questions all along or at the end, either one. And for this course today, to get credit, you have to attend at least 80% of the time. I'll be looking at the reports after the webinar to make sure that you qualify for credit. And we cannot give credit to anyone who's not registered for the class and logged in. So if you have people sitting around you that aren't registered, they won't get credit from us. It'll be only the person that's logged in and registered that will receive credit. You'll get a certificate from this class probably within 3 weeks. Otherwise, you'll give Dee Bryant a call here with the Department of Labor at 919-807-2877. And actually, that number has changed. I would call actually 919-707, 7864 and or 7876, either one to tell us that you haven't received your certificate. So anyway, those are the little housekeeping things we need to get set aside. Again, I have a small class today, and that's good. People may be very busy, who knows, but like I said, it's a small class. But and we're talking about heat stress. And from me, I can personally relate to heat stress due to jobs I've had prior to finishing high school, such as mowing lawns and working in tobacco at a time when we had primers, tractor drivers, handers, loopers, and hangers in the barn. The fields in the barn were extremely hot in those days. In addition, I remember the summer where I worked in golf course irrigation construction, digging ditches and laying pipe. So most of my career, I've not worked in extreme heat, but when I was in high school, I had those experiences. And you may have had experiences such as lifeguarding or working in construction or even in your present job. And we have some folks that are in the construction industry right now logged in. So if you work directly in the heat or supervise those that do, that of course is a good reason to be in this class. So those are my opening comments. The one question I want to go ahead and ask, if you're in extreme heat conditions working in direct sunlight, what should we provide to prevent heat illness? What are the things that we should provide? I'll let you go ahead and type that in. Water, excellent. Shade, hydration, water, and rest. So there you go. You've got them all covered there, water, rest, and shade. Now, is heat stress a concern only for outdoor workers? No, it's not. So you may work for a brick manufacturer, you may be around a kiln, you may work in a boiler room, you may work at a sawmill, or you may be working around some kind of industrial oven. So we can have heat stress issues in indoor or outdoor conditions. Most of the issues we have are with outdoor workers, but again, we do have cases with indoor issues as well. So go ahead and advance our slide here. And this is what we'll cover today. Of course, we'll cover definitions, causal factors, health effects, prevention, engineering controls, PPE, work practices, acclimatization, reacclimating, administrative controls, work monitoring, and training. So if you're with an employer where you're sending workers out or you're working out in extreme heat conditions, either indoors or outdoors, if you're sending people out in extreme heat, then you should have a heat illness prevention program and a plan in place to prevent these injuries and illnesses. So we're going to get some ideas for what we can do here in the webinar today. Now, if you work in extreme heat or supervise those that do, type yes. Do we have anybody that works? Okay, so we're getting several yeses there. And we may have a couple of North Carolina Department of Labor employees that do inspections in heat as well. Now, have you ever had a job working in extreme heat conditions? Have you ever had a job working in extreme heat? And a lot of you have. Now, one thing you'll run into nowadays is there are a lot of young workers out there who've never worked in extreme heat. Like the example I gave, I worked in tobacco. Here in North Carolina years ago, tobacco was even a bigger crop than it probably is now. And a lot of high school kids would work in the tobacco fields, priming tobacco, and in the old days, hanging tobacco in barns. But a lot of young workers have never worked in extreme heat and may not be even willing to work in extreme heat. So that's what's creating an industry for migrant farm workers to come into the state to do this work, because sometimes nobody else will do it. Now, many of you in the class today are in construction. If you're in the construction business, you're going to be working in the heat many times, or most of the time, or much of the time as well. And we know that heat stress is not just a concern for outdoor workers. Now, can heat stress lead to a fatality? Can it lead to a fatality? Of course, the answer is yes. We're kind of lucky, and I don't really want to jinx ourselves, not that I believe in jinxes, but here in North Carolina, it's been a few years since we've had an occupational heat fatality. And it may have been somewhere like 2011 or 2012 or 13, somewhere in that range, maybe even 2014. But it's been a few years since we've had an occupational fatality. Now, we do have occupational illnesses and injuries to heat. We still have those. And as long as we still have those, we still have the possibility of a fatality. So that's, again, why we're covering this topic today. We don't want injuries or fatalities due to people working in heat conditions. Now, we would never do this as an employer. If you're an employer, you would never do this to say somebody working outside in the heat. If you want to hurt somebody, you would do all these things, and you would have probably a serious illness or injury as a result. We would put them in dark clothing. We would put them in wool, nylon, or polyester clothing. Now, we're not talking about employees so much, but are there people that go out in the heat and perform in wool clothing? Who would that be? Now, these aren't employees, but who performs in wool clothing? We're getting close to football season. Now, the football players don't wear wool. We know that. But who performs in many cases, wool clothing? Okay, a mascot could. Good answer. But if you're ever in the marching band, some of the uniforms, even today, that are worn are made out of wool. And if you're ever in the marching band, they would have band competitions in North Carolina in the fall. And a lot of times they're very hot conditions. And you would have these kids actually falling out from the heat, essentially. So a lot of these tips that we talk about today not only apply to employees, but also volunteers and other people and kids. So we want to use these ideas when we're at home working, or anytime we're out in the heat. So now nylon, most people don't wear nylon out in the heat. And I will tell you that years ago in the 60s, they used to make a shirt out of nylon, short sleeve shirt, bright, colorful, looked like a golf shirt. It was called Banlon, Banlon, Banlon shirt. Beautiful shirt. They they were good wearing shirts, but as far as heat, it would trap the heat in. So you don't see too many Banlon shirts around anymore because they were made out of 100% nylon. Now, the good news is today we have performance fabrics, and there are a lot of textiles out there that they're excellent for working or working out in heat, like performance fabrics. Now, we're going to put somebody in direct sunlight. Now, some of you still have to work in direct sunlight. If you're working in a field, um, there's no way around it. So can we control that? Maybe we can, maybe not, depending on what your work is. No water provided. Now you may be losing water from your body, and you will in extreme heat, and not even realize how dehydrated you're getting. So we're going to provide water. Now, as an employer, some of you are employers, some of you are employees. Is there an OSHA requirement to provide water for general industry and construction workers? Is there an OSHA requirement? That's right, Keith. It is an OSHA requirement. So if you're working for an employer and they're not providing you water, you'll take them to the construction standard 1926.51A 1, 2, 3, and 4. 1, 2, 3, 4, 5, 6 actually. You'll take them to the construction standard, and you'll also take them to the general industry standard 1910.141B1 IIIIIIV 5 and 6. So it is a requirement in general industry and construction to provide water to your workers. And it doesn't matter whether they're working in heat or not. You've got to provide water in the workplace for your employees to drink. Okay, so that's water. Heavy physical work, such as using an axe or shovel. So when you're working hard, you're going to produce a lot of body heat. The harder you work, the hotter your body's going to get. And using an axe or shovel is a pretty extreme physical work. And so a lot of companies, instead of having people using axe and shovels, they're using power equipment. So instead of an axe, they use a chainsaw. Instead of a shovel, they're using an excavator. So the reasons to use this other work is to not overwork, overheat your employees. These machines are going to do a lot faster and easier. A high heat index. You're putting somebody in the extreme heat index conditions. You're not giving them breaks, and they don't have a hat. Now, what is an ideal hat for working in the heat? What is ideal? Not just a hat. What kind of hat? Okay, straw, good answer. Okay, full brim, breathable, great answer. So, my grandparents, when they were alive, I mean, they were farmers. My grandparents had a farm in the mountains of North Carolina, and they were dairy farmers, and they grew crops as well. But I remember the hats that they would wear, and they were full brim, breathable hats. I don't think I ever saw my grandfather wear what we call a baseball hat. Now, a baseball hat might be better than nothing, but the type of brim and the way a baseball hat's designed would not be quite as ideal as a full brim, breathable, like Stephen says, hat, or Shonda, the mesh hat. So a full brim hat. Long work day. In the years that I worked in tobacco, those years, um, sometimes we would work 10 or 12-hour work days in the heat because we're trying to finish a field and a barn. We're trying to hang a barn full of tobacco. So sometimes you have a long work day. And one of the most important things we'll cover today is worker not acclimated. Don't assume that people you hire in construction or in the work in the fields or work outside in the heat or even work inside in extreme heat are used to it. So you bring somebody in on day one and you're working them 8 to 10 hours in extreme heat conditions. A lot of the heat fatalities and a lot of the heat injuries we've seen are for people who just started their work. They haven't worked more than a day or even a week, and they get sick or they may even die. And we'll talk a little bit more about acclimatization here in a minute or two. So we'll go ahead and go to the next slide, and we'll talk more about water. Now we have to provide water. OSHA says you have to provide water to employees, and you have to have an adequate supply. And it has to be potable water, which that means drinking water. If you're on a construction site, you're going to have drinking water maybe and non-drinking water. You might have water that you use to keep dust down on the site. Well, it's going to be marked not for drinking. So you want to indicate that this container indicates drinking water or any other term to let people know that you can drink from it. Now that slide there on the second bullet, there's a typo there. There should be a dash between 2 and 4. It's not 24 cups of water per hour. That's 2 to 4 cups, 2-4 cups per hour per worker. And ideally it would be 50 to 60 degrees. But if you ice and water down, it's probably going to get colder than that, and that's okay. But if you could control the temperature to 50 to 60, that'd be ideal. But if you're in construction, you're going to have a cooler like the one there on the right, and you'll have ice water inside of that cooler. The container has to be closed. When you have portable containers out there, you can't expose that water to the conditions. You have to keep it clean and sanitary. So that lid has to be on there, and you can't use dippers or cups or bottles to dip out of a container because we're talking about sanitation here. In the old days, you may have seen dippers. They might have been aluminum or stainless steel dippers that people would dip water with, and you might have seen that on farms or somewhere where they had a spring. But no dippers or bottles or any way to dip out of a container, no share container. And if you're in industry and you're providing water, you're not allowed to share containers there as well. You can't share cups, dippers, or bottles between employees. It's just a hygiene, sanitation type of thing. Now, water, drinking water, potable water meets the EPA standards for drinking water. So it has to meet at least drinking water standards. Okay, and it could be bottled water. That would be okay. You got it iced down, and you give somebody an entire bottle of water. Now, enough about water. Let's go ahead and go into some definitions. Let's think about heat stress. Now, you're putting up a worker in an environment inside, maybe in a boiler room, around a kiln, outside in a field or an open construction site. You're putting them out in the environment. And let's just say it's sunny and hot, and you're getting a lot of direct heat from the sun and radiant heat. And so you're going to take that heat from where you're working, and then the heat from your body, that's the metabolic heat load. I'm working, so my working body's producing heat, and then I'm adding the heat from the environment to that. And then I've got to subtract that heat from lost environment or evaporation. So you're going to sweat. So your body's trying to stay cool. You've got this heat load on it, and it's trying to cool down. If you heat it up faster than the body can cool down, you're going to have heat stress. If your body cooling system shuts down, you're going to have heat stroke. So it's your body trying to battle the heat load that you're getting from the environment and the work that you're doing. Now, heat strain is your body responding to heat stress. Now, the factors that we talk about with heat stress are the temperature. How warm is the air outside? How much humidity is in that air? So if it's hot and high humidity, you're going to have a higher heat index, and it's going to feel like it's actually hotter than it is. And then you have radiant heat, or direct heat from direct sunlight or a furnace. And then the other question you would ask is, do you have circulating air? It's like when you're at the beach. A lot of people get burned at the beach from the sun because they don't notice how hot they're really getting, because they have the breeze off the ocean hitting them all day long, and they're getting overheated and even burned by the sun because that air is kind of fooling them into thinking that it's not as bad as it really is. So if we can control temperature, humidity, radiant heat, and velocity, then we're doing a good thing. But we're going to control as much of this as we can, these environmental factors. Now, some of these causal factors, how old is the employee? Now, the people that are most prone to serious heat issues are very young people. Now, these, like toddlers, somebody below the age of 5, well, they're not going to be employees. But you could have older employees, people that are hitting their 60s, late 60s, or maybe late 50s are going to be more prone to have a heat injury or illness than a younger worker. If they're extremely overweight, if they're extremely unfit, they're going to be higher risk. The other thing we're going to look at is how acclimated are them to the heat. Did we just bring them in and throw them out there in the heat working a long day, or did we ramp up the exposure time? And then their body metabolism, it varies from person to person. Now, hopefully, they don't use alcohol or drugs, but alcohol is a diuretic, so that's not good. And drugs, it's not just illegal drugs, but there's some prescription drugs that can make you more prone to heat illness. So if you have an employee that's sick and they're on some kind of drug product, they've got a prescription, there may be a warning about do not work in direct sunlight or work in heat conditions while taking this medication. And if you have other medical conditions like hypertension, that can also affect your sensitivity to heat. Now, at this point, let me go ahead and stop for a second and ask, are there any questions or comments? Or are we good to go? How are we doing? Okay, everybody's good. All right. And I'll try to look at your comments all along to make sure we haven't missed anything. And we'll go to our next slide. Now, somebody who's ever had a heat injury, like say heat stroke or other heat injuries, can predispose them to being hurt again by the heat. So once you've been hurt by heat one time, you're a little bit more high risk than somebody who's never had a heat injury. And of course, the type of clothing worn must be considered. So what about fabrics? What are some good fabrics for workers to be wearing in heat? Cotton, great answer. And you have also some, Wesley said cotton, you have some other performance wicking fabrics. Light colored, right. Light colored, dry fit, like Shonda says, a performance fabric. These modern fabrics are great. So something that's light colored, lightweight, and breathable is excellent. Now, we have in North Carolina, unfortunately, there are people that can't always wear that type of clothing or gear when they work. Um, what kind of workers are probably more likely to be overheated than almost any others? What type of work? And these are all good. Welders, a great answer. Okay, let's keep brainstorming here. Welders, a good answer, not what I'm looking for. Electrical, good answer, not what I'm looking for. Construction is a great answer. But even more than construction, if you're looking at the news, what workers probably get overheated more than anybody else? The workers that are getting paid, they have to put gear on. Gear. Okay, lawn care, another good answer. What workers have to put on full gear? Firemen, firefighters. Exactly. Workers have to put on full gear. Firemen, firefighters. Exactly. So turnout gear for firefighters is not cool, and they have to, I mean, it's not cool as far as temperature is concerned. And firefighter can get overheated easily. So they're putting all this protective gear from the actual fire itself, and they're doing physical work, and they easily can become overheated. So they have protocol and procedures to try to prevent injuries to firefighters from the actual heat conditions they're running into. So it's an extremely hot day to begin with, and then they're fighting a fire on that day. So the heat load on them is tremendous. Okay, now we talked about colors. Light colors reflect heat versus absorb. So light colored, lightweight cotton would be really good to be wearing outside or near heat. Now, a lot of you or most of you are probably familiar with the heat index, and if you watch the weather every day, you know there's going to be a forecast, and they're going to talk about the temperature and the heat index. And most of us nowadays, we keep up with that because it's not just at work. We're talking about our family, our kids, everything we're doing outside, we're doing yard work, whatever, we're looking at that heat index. So the heat index is calculated from the temperature and humidity. So you might have a day where it's 85 degrees outside, but it feels like 91 because you figured in the humidity. Now, how many of you have an app for your smartphone that will show you the heat index and how to calculate, or actually what to wear in high heat conditions? How many of you have an application on your smartphone for that? If you don't, I'm going to tell you about it. Okay, Randall's got it, and I want you to get it too. NIOSH, Shonda, that's right. The OSHA NIOSH Heat Index app. Now I'm going to turn my camera on, so just ignore the guy in the background. You don't want to see him, but I want to show you my phone. And I'm going to turn my camera on here and show you the app. See that red app, red and yellow? That one's produced by OSHA or NIOSH. And what you do when you turn that app on, it's going to look at your local conditions. And the heat index today in Raleigh, downtown Raleigh, feels like 88 degrees and it's low risk. Now this app also, it will show you the precautions to take, the first aid. There's a lot of good information on that app um, to tell you what you to do when you have heat stroke. Again, a lot of great information. It'll also give you the forecast for the area. So I'm going to go back to heat index, and there's an hourly forecast on there. Now I'm going to go ahead and turn this person off your live video so you don't have to see me right now. So let's go ahead and close that and go back to the slides. If you're a worker or you employ people that work in high heat conditions, I highly recommend that app. And that app, you can get it for your smartphone, for Android or Apple devices. It's called the OSHA NIOSH Heat Safety Tool. And if I'm a supervisor, manager, or a worker, I can keep up with the heat index, and I can adjust my work or my schedule, whatever, based on that heat index. And it's the same heat index breakpoints here as this slide shows you, but it gives you a lot more detail. So if you don't have that app, I'd highly recommend it. If you're at home this weekend and you want to do yard work, it might determine what day you do the yard work on, or if you're working in a high heat index, what precautions you need to take. So that is a great application. So again, I recommend that app highly. Okay, so we find that people are getting sick from the heat. So we're going to talk about heat rash, heat cramps, heat exhaustion, and heat stroke. And before we get into the detail on that, I want to mention that California OSHA, they're a state planned state just like North Carolina is. They did a heat illness study, and they looked at all the people during a particular period of time that got sick from the heat. And they found that half those people got sick on the, or maybe even died, on the first day of work. Welcome to our company. We're in construction. We pave roads, like for example, or we put roofs on houses. This is your first work day. The heat index is high. Do the best you can. Let's get out there and do work. So you got a 50-50 chance of that person to get sick or maybe even die on day one. Let's say they didn't get sick or die on day one. 80% of those people that got sick had been on the job for 4 or fewer days. So if you have a company that employs new people, you need to acclimate them to the heat if you're having them work in high heat conditions. So that's a change you can make to some of your policies if you need to prevent people from getting sick or even die on the job, which we certainly don't want that. Now, the different things that can happen to us, the lowest level would be a heat rash, and we'll see red papules on your body in areas where your clothing's restricted. Your sweat ducts might become plugged, and you're not able to sweat quite as easily. That would be a heat rash. So if you had the app, that OSHA app, you could go into heat rash, and it would tell you what to do for that. So now, and going to the next slide, it would give you the same information. What kind of clothing are they wearing? We want to keep the skin dry. And if they're in this heat every day, do they have cool sleeping quarters, like if you're an agricultural worker, like a migrant worker, or calamine lotion? Those are good treatments. And then we're going to move to heat cramps. So we might have a lot of quick water loss, sweating, and dehydration. And like I said, you see the symptoms: shriveled skin, sunken eyes, dry mouth, and tongue. The, the employee may become dizzy, weak. They may have headaches. So we're going to take them away from the direct work to a cool area where they can rest and give them fluids. Now, in the world out there, besides construction workers or field workers, uh, what people that aren't workers, what types of people get heat cramps a lot? I'm not talking about in the workplace. Where would somebody get heat cramps? What activities? Athletes. That's exactly right. So athletes, if you have marathon runners or football players, uh, you'll see people pulled to the side or they have to drop out because they're having heat cramps. Now, heat exhaustion, we're getting more and more severe. Somebody's getting hotter and hotter, and the body's moving more blood toward the outer body to cool off, and the brain is getting less blood flow. So that's why you're going to feel dizzy, maybe have a headache or be fatigued. Your pulse rate goes up. You might get sick, have nausea, vomit, or faint. That's heat exhaustion. So again, we're getting very, very serious. Now, if somebody going through heat exhaustion, we don't stop, we don't do anything, we keep working them, that could lead to heat stroke. And that's the one we certainly don't want. So again, we're going to move them to the shade, cool them off, elevate the legs. If you have a fan, wet towels, and we want to give them liquids like sports drinks or water. We're not going to give them alcohol, of course, or which works against our body or actually dehydrates us, or caffeine, which does the same thing. Be careful with caffeine. Caffeine can work against us as well. And if things get worse, they may develop heat stroke, which is the most serious. Now, heat stroke, we got a medical emergency. We have no time to waste. Somebody's going through heat stroke. What's happening is the body's overheating and the cooling system of the body shuts down. So your body stops sweating. You got somebody overheating. They're turning red. They're not sweating. Their core temperature rises. Very, very dangerous. So obviously, we don't want that. That's a case for calling 911. You're not wasting any time. This person is having a heat stroke. This could be fatal. We want immediate first aid action and immediate response from 911. Okay. Now, with this heat stroke, again, they're going to have typically dry skin, confusion, nausea, extreme body temperatures up, maybe even up to 105.8, extreme temperature. They may go unconscious. So we're going to move them to a cool location, loosen their clothing, immerse them in cool water, wrap them in wet sheets, apply cold compresses to the head, neck, and groin. Again, serious. As soon as you see those conditions, you're calling 911, but you're doing something in the meantime because that time is critical. Now, one thing I want to show you is federal OSHA did a study, and that study was from 2008 to 2014. And they looked at all the people that died that were employees in the United States between those years of 2008 and 2014. What were they doing? What types of work were they doing? Now, what I want you to think is, are any of these people's main jobs or duties that they do for you, or are they jobs that they do once in a while? So it could be their full-time duty, or it might be something they do periodically. But when they're doing these jobs, uh, they're high risk. So if you want high risk, they're doing this work during the first week of employment and they haven't been acclimated, it could lead to a fatality. So they were remediating asbestos, trimming weeds, finishing drywall, connecting steel, general construction, recycling, carrying mail, ship cleanup, bulldozer operation, oil and gas well drilling. And here's a typical construction picture. You know, those guys are going to get hot doing that work. We got some roofers here. You could be digging trenches, painting, farming, cutting down trees, installing turf, highway construction, repairing roof, collecting garbage, harvesting cantaloupes or harvesting any fruits or vegetables. Now we got a arborist here on the right. He's using a chainsaw. At least he's not using a manual saw, but somebody cutting trees, fighting a fire, laying brick, changing tires, landscaping, working at a golf course, harvesting here pistachios, repairing AC, paving. Now here's catering an outdoor event. So catering an outdoor event is physical, maybe not as physical as some of these others, but here's somebody that was a caterer that died on the job from exposure to heat. And again, picking strawberries, cleaning up construction, installing a swimming pool, mowing, pouring concrete, pruning trees, shoveling soil, climbing tobacco, erecting rental tents. All these people doing this during that period of time, one of them died from doing these particular tasks. Now, OSHA does not have a standard for heat stress. So if you have an OSHA regulation book and you're looking for heat stress, you're not going to find it. So when OSHA compliance officers go out to inspect, we have agricultural compliance officers and then we have other compliance officers. When they go out and they see extreme exposure or somebody exposed to a hazard and they need to write a citation, what they'll do is they'll use what they call a general duty clause. It allows a compliance officer to cite something for something that is not in a regulation book, like heat stress. So the compliance officer has to prove that a person is exposed to a high heat hazard, and this could cause a serious injury, which heat can do. So serious injury is something beyond first aid. A recordable injury, anything from between first aid and death would be a serious injury. And there has to be a way to correct the situation or lower that risk. So a OSHA compliance officer can write a citation for a heat hazard. Now what happens a lot of times, because imminent danger and fatalities are top priority for OSHA, when they respond to an investigation, a lot of times the person's already dead, and then they're trying to investigate a case, and then they would be using general duty clause. But they could be doing a normal inspection and see an issue as well. Okay, so that's general duty, and I've already covered what the general duty means. Employee is exposed to a hazard. It's recognized in the industry. It can cause serious injury or harm, and there's a way to correct it. Now, with heat, we want to eliminate or minimize the hazard as much as we can. So we want to spend most of our effort on engineering controls and then go to work practice controls, which are like procedures and policies. And then personal protective equipment is our last resort, because we have to depend on employees wearing it right, using it right, taking care of it, and using it properly. So these are the different methods that we're using to minimize risk to people working in heat. So for the engineering controls, what are we doing? We're using general ventilation. So we're diluting hot air with cooler air. So um, let's say in a professional football game, you'll see these fans on the sideline. That would be general ventilation. If you're inside a building, general ventilation. If you're working construction in a field, you may not be able to provide general ventilation. You might be depending on the wind to keep you cooler, but there may not be any wind. So will general ventilation help? What about air treatment, air cooling or air conditioning? So if people are working outside, air conditioning may not be an answer, but there are some blowers that are like portable air conditioners that will blow cold air onto employees so they could take a rest period and sit in front of these units. That might be an option. Local air cooling, again, those portable units, fans, heat conduction. Um, uh, you might be able to insulate the heat source to keep it away from the employee, like if you had furnaces or people working around hot items. And then you have other heat sources where the you have radiant heat that's moving from a hot to a uh, cooler place. So again, some of these controls you may or may not be able to use uh, in your work site, depending on your situation. Now, what are the three main things we talked about to begin with? What are the three keys? Like say somebody's working outside in the heat. What are the three things we're going to want them to do? You've already mentioned them once. Okay. Okay, water, rest, and shade, or hydrate, rest, and shade. Exactly. Now, so on a construction site, depending on what kind of construction you have, they may have erected a canopy or tent to provide shade, and they're moving people in and out of that tent. Or some construction companies, they'll have trucks there, and they'll let people take a break, and they'll crank the truck up, run the AC, and let them sit in a running truck with AC on for 5 minutes. But we're letting them go to a cool, shaded area, letting them rest, recover, and provide them water, sports drink, or whatever appropriate uh, drink you have for them would be. Okay, so let's move to the next slide. Now, this first bullet says perform work activities during the cooler periods of the day. Well, that might not be an option for you. These are your hours. This is when you have to work. But if you're a construction company or a contractor and you're not working with other subcontractors, you're not on a schedule on their site, and it's just you're the only contractor there, you might be able to adjust your hours. The supervisor might say, look, I've done a look at the forecast for the next week. We're going to be in extreme heat. So we're going to start our work days at 4 a.m. We usually start at 6. We're going to start at 4. We're going to try to keep you out of the hottest part of the day. Or we're going to schedule around those hotter times of the day. Or we may even have you work at night. Now, it could be very hot at night, but we're going to try to change the schedule. And there are companies out there, their work schedule is driven by not only the rain, but the heat index. Minimize activity in the hot area. So you may be rotating people in and out of the hot area, but everybody might be in the hot area. Now this says slow down the work pace. Now that sounds funny because you're out there trying to make money for a business. You're trying to get the work done as fast as possible. So let's say you can't slow down the pace. What could you do? What could you give workers that would increase the pace but lessen their risk of heat stress? what could you give them where you don't slow down the work pace, but you get more work done? What could you give the workers? Uh, you could give this, you could give them something to do that. Okay. Now the cooling tiles, that's a good control. But let's say I have somebody out there chopping trees down with an axe. Instead of slowing them down, what could I give them besides using an axe? Chainsaw, of course, they need to be properly trained. Different equipment. Chainsaw, of course, they need to be properly trained. Different equipment. So, especially in the field of construction, we see a lot of automated equipment. Not only is it getting the work done faster, but the worker is not physically doing as much work. Their bodies aren't producing as much heat. They're controlling a machine versus them being the entire machine. So again, if you can slow down the work pace or add workers, that's good. Maybe you can do that. Reduce the number and duration of exposures. So you have people that work in high heat areas and lower heat areas. You rotate them in and out of the hot area. Wear proper clothing. Provide recovery areas, rest areas, and decrease the work rate. And like I said, you might be able to decrease their work rate and use other equipment so you don't get off your schedule. But the work rate is a big deal if you're looking at the employee. Now we could give them personal protective equipment, special clothing to help keep them cool. It may be reflective, or you may be giving them ice vests, wetted clothing, or scarves or bandanas. Um, water-cooled garments, hoods, vests. Now, I must admit, I've never seen a water-cooled long john, but they must exist because whoever wrote this class originally must have seen that. But any kind of water-cooled garments and or water-cooled suits. In NASCAR, these drivers, uh, they have water-cooled suits, a lot of them, again, to keep them cool. Circulating air, compressed air vortex tubes. So you may be able to supply this kind of equipment. Now, one of the most important slides that we cover today, if you have workers that work in extreme heat and you're hiring new workers, it should be part of your heat illness prevention program to acclimate them to the heat. So let's say you work in construction and let's say you put roofs on houses, the roofers. Day one, they're not acclimated to the heat. You let them work a half day, and then the next 2 days you increase the time 20% per day, and the final 10% on the third day. So that's going to lessen their risk of a serious heat injury or illness as you ramp them up to do the job. So you want to acclimate them. Now, if you have workers that work in extreme heat and they've been gone for a while, if they were lucky enough to take a vacation for 2, 3, 4 weeks, and they come back to the job working in heat, it's a good idea to work them 50% on day one and 20% for the next 2 days and the final 10% on the third day. So you want to reacclimate people to the heat when they come back from some kind of absence. There could be lots of reasons that people would take some kind of absence and then have to come back. You may work in such heat that you have ways to monitor employees' heart rate and temperature and body water loss. I mean, you may need to get into personal monitoring. And of course, one of the most important things we do is anybody that works in extreme heat, they need to be trained. They need to know what the hazards are. how they can protect themselves, what kind of things can make them higher risk, like certain medications, or they're older. They need to know what the signs and symptoms of heat illness are, because in many cases it's not going to be them, it's going to be their coworker. The coworker is overheating, they're not drinking water, they're getting dizzy, and they really don't know why. So your coworker is going, oh my gosh, my coworker is getting overcome by heat. I need to do something. So they need to recognize signs and symptoms. If you have PPE to keep somebody cool, train people on how to use it correctly. First aid, what kind of first aid to provide, and train people on proper first aid. And what can these heat illnesses do to you as far as your health? So you would give people a training class on working in heat. Now, the one thing companies do, they'll tell their people about the urine color test. If your urine color is getting too dark, that means that you're not hydrated enough. So a lot of times online or in the training materials, you'll see a chart, a urine chart of different colors of urine. That if you tell the employees, again, if your urine is dark colored, you're not really drinking enough water. That's dangerous. So anyway, this excessive heat, of course, can seriously make somebody ill, can kill them. And the keys are knowing the hazards and how to actually prevent them. Now, again, if you're an affected employer, if you're in the construction business or you work somewhere where a lot of people are exposed to extreme heat, I would recommend you put a heat illness prevention program. Go ahead and put it in writing. These are all the different things we do. When you train your employees, you're going to train them on what you do. And you may even change your schedules or whatever, depending on the heat index out there. You're going to talk about how you acclimate your employees to the job. You're going to talk about their access to water and tell them to drink water even if they're not thirsty. You're going to talk about where do they go to cool off. If they're inside, it might be an air-conditioned room, vehicle, fans, shaded areas. How many rest periods do they get? Do you have cooling vests? Again, are they trained on heat stress? And who's trained on first aid? Somebody needs to be trained on first aid. So these are the different things that we can do to hopefully minimize overexposure to heat. Now, this was a short session today. Does anybody have any comments or anybody have any questions? Like I said, this is pretty easy to understand. We had a very small class, so we didn't have as many questions or chats as we do with a large class. So we can have up to 100 people in our class, but we don't have many here. There's 3, 6, 9. We have about 11 or 12 people today, which is very small for us. So I've got, we're pushing on about 11 o'clock. Appreciate your time today. Hopefully you learned something you didn't know. This presentation is on our site, labor.nc.gov. You can print it out, study it, train people using it. But when you train people, make sure it's site and company specific for what you do. You're welcome, Stephen, Rhonda. We're going to go ahead and call this the end of the webinar. Here it's right at about 11 o'clock. We're going to call this the end of the webinar. Again, I appreciate your time. And I'll stay on here just a couple more minutes just in case any of you need anything. Wesley, Randall, Jessica, I'm glad you downloaded the NIOSH app. I think you're going to be using it a lot. I use that at home. I use it at work. Again, you'll use it a lot. Wesley, you stay cool too. You're welcome, Randall. And so again, it looks like we may not have any questions right now. So looks like I'm going to go ahead and log off. So again, it's been great having you today, and we'll look forward to seeing you or hearing you about you on the next webinar. Joseph, you're welcome. So again, all of you have a great day, and we'll see you later.